Hey scientists, it's Mrs. Aquilia. I'm here in my kitchen science lab, and this is Science Experiment of the Week number 7. I am going to do 3 really cool things that are all going to prove the same thing, and I'm going to tie them together and explain it all at the end. The first thing that I'm going to do is I'm going to take this mug, which as you can see is full all the way up to the top with water. I just colored it green because it's easy to see, okay? Clearly full up to the top. Now we would think that if I tried to pour this water into this mug, it's just going to spill right over because there's not any room left. Well, I don't know if this will all fit, but we're going to see what happens when I try to put more water in this mug even though it's full already. Get ready. Do you see what's happening? Do you see that the water is actually now above the mug? This is the mug, and you can see that the water is actually bigger than the mug. Look at that. How is that possible? Look at that shape that it's making. It's almost like a round, like that. You know what that's called, boys and girls? That's called a dome. That's the name of that shape. It's called a dome. It's almost like a rounded bubble on top of something, when something is like bubbled over the top. Look at how far above the top of the glass that water is now. I'm really surprised that I was even able to add this much. Oh, it's spilling over. But still, check this out. How cool is that? Look at that big dome. Okay, let me get started on the second activity. So for the second activity, what I have is just a regular penny, a small cup of blue water, and an eyedropper. And what an eyedropper does, my pre-K scientists know all about the eyedropper. You put it in, and it lets you drop water or whatever the liquid is, 1 drop at a time. Now, I know that most people probably don't have an eyedropper at home, so you may not be able to do this one, but it's still going to be cool to watch what I'm doing. So what I want to do is I'm going to start putting these drops of water on top of the penny. And I want to see how many drops of water will fit on that penny before they spill over the side onto that paper towel. Okay, so you might want to pause for a second, make a prediction, tell the person you're with, and then come back to me. But I'm going to go ahead and get started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to stop for a second. Look at that shape. That's that same dome shape, isn't it? It's that same dome shape that we saw on the mug of water. You could see it much better on the penny. But look at how it's able to rise above the penny instead of spilling right off, just like with the mug of water. Okay, so let's continue. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 put us over the top. But still, 30 drops of water were able to fit on this little tiny penny. Amazing, right? So now for the third part of this activity, I have a piece of wax paper, and wax paper is a special kind of paper that will not absorb liquid. It's got a coating on it that's almost kind of slippery. Your mom might have some in the kitchen. I have 3 little cups of colored water. I have a toothpick and I have my eyedropper. So I'm going to start by just putting some drops of water on the wax paper. And you know what? This isn't even the cool part yet, but this is already pretty cool because what you'll notice is happening is that they're not running together. Oop, got a little mini one there. These drops are not running together. They are all by themselves. And I want to show you from a different angle. Do you notice that shape? It's a dome. It is the same shape that was on top of the mug and on top of the penny. And when the water drops come out of the dropper, they automatically come out in a dome shape. Look at that. Or I should say that they form a dome shape when they land on the wax paper. So what I'm going to do is I am now going to take a toothpick and I want to show you how these dome-shaped water droplets can move around. They don't break apart. They don't turn into a puddle. But look what happens when I try to put them together. Ooh. Look at that. It's taking them, moving them around, and I'm joining them. What do you think will happen if we put a red one with a yellow one? Yup, orange. Now, I'll tell you the truth. Even if you do not have a eyedropper at home, if it's okay with your mom, you can actually just stick your finger in here and just kind of shake it on here and make droplets that way. See how that works? But check with your mom first because it takes a while to come off your finger. So, boys and girls, why is this possible? How is this a thing? How is this a thing that I'm able to do this? And look what happens if I move the paper. They just fly all over the place by themselves. So let me clean this up and I'm going to explain this all to you. Okay, I'm back. So if I asked you to think of things that were sticky, you would probably think of things like glue, tape, honey, Post-its. Post-its are sticky. There's no way you would think of water, right? I don't think any of us would say water when asked to name things that are sticky. But you know what? Water is sticky. That's what I just proved to you. Everything is made up of these little itty bitty tiny things called atoms, and we can't see atoms with our eyes. They're just too small. We need a microscope. But what we saw is that the water atoms are sticky. They're attracted to each other. They want to be together because you know what? Each water droplet is made up of like a zillion atoms. Think about how small a water drop is, and if an atom is so small that we can't see it, then there's like a gazillion of them in a water drop. And the water drop is just showing us that all of these water atoms are sticking together. So I just proved to you that water atoms are something called cohesive. The word cohesive is broken down into co, which means together, like cooperate, and hesive, which means to stick. Water atoms are cohesive. They stick together. Water atoms are sticky. Boys and girls, you like my new kitchen bulletin board? Yeah, right next to the bananas. So, I just proved to you, because I am a scientist, that water atoms are sticky. They will always stick together and make that dome shape. And I know that you're just dying to try this stuff because it's really pretty cool. So I'm hoping that when you do, you will continue to send me pictures and videos, and I look forward to that, and I will see you next time, boys and girls. Bye.